If you want to know about basics of dynamic memory allocation, please watch the previous video from the list in the description below. Here we focus on how to code dynamic memory allocation to manage a dynamic array of objects. I will cover the following. One, how you can create a dynamic array of object. How you can make use of it, and how you can release or clean it up. I will make use of this structure student as a type to create the objects. We want to create a dynamic array of objects where the objects are going to be of this student type. We can use this syntax to create a dynamic array of objects. New followed by the type. In the previous video I used integer type, but in this case we want to store the student type objects, so the type is going to be student. And if I want to create an array, I need to specify the number of elements that array can hold. Here I am going to be using a variable number of students, and for that I need to define this variable beforehand. And I actually want the user to enter the number of students. Therefore, let me have a prompt text to ask the user to enter the number of student he or she wants. Then I read it in the variable number of students. Now we have a number of students, and it is it contains the value which was entered by the user. Now this entire expression actually creates a dynamic array and returns the address. We need to store that address. Where we want to store that address, we need to typically we store that address in a pointer, and the pointer is going to be of type student again, student pointer. Let me call this SPTR. When you create a pointer, it is always a safe practice to set it to null PTR immediately, and then we can set this pointer to the address that is written by this expression. Now let me have a text. When I execute this program, I want to have something that indicates that this task has been completed. Let me make sure that this code actually works. So I want to do compilation and linking and execution of the code. This is a command to compile and link. We have an issue. I think there is some kind of typo. Let me go back to the code and try to correct it. Yeah, it should be number of students. Yes. So go back to the terminal. Now we have this warning issue. This is I'm going to be ignoring this, but this is not a problem because I'm not using this pointer. So I think there is still another typo. Yeah, this pointer is not being used, so I am going to be ignoring that warning for a moment. Now at least we can see that we can execute this code now. So how many students, and I enter 5. So now dynamic allocation completed. That means the code is working fine. Now this was a dynamic memory allocation task. Now the next task I want to do here is data entry. Here we want to populate this dynamic array with the data. I mean the objects of this array with data, which is the name and ID. We want the user to enter the name and ID of the student objects in a loop, in an iteration. So for that, let me have a text that will actually indicate that the program is expecting student information. Then in the for loop, we already have the size of the array, so number of students. Inside I want to put a prompt text. This I is an index that actually keeps track of the student numbers, therefore but we don't want the student number to be 0, the first student. We want first student number to be 1, therefore I plus 1 would be the first student number, and ID and name. Then in the next line we have a cn statement to read ID and name, but we want to read directly in the element of this array. So we can access the element, for example first element, using this syntax by putting index in the bracket. If you put 0, that will give you access to the first element. With 1, it will give access to the second element, and so on. Since we have iteration index keeping track of the first, second, 0th, first, second, or third student, so we put I here, and then ID. The first entered item will be actually copied in the ID of the first object, and the second entered item will be read in the name member of that object. So now with the completion of this loop, we will have this dynamic array actually populated with the data. Again, a text to indicate that this logic has been completed. The next third task we want to do here is something called pre-processing, because when you enter data, it's always you do some processing, you get some information, or you utilize that data. So this is a processing step. In this processing step, what we want to do is we actually want to determine the maximum or minimum values of ID across or amongst all the objects in this array. So for that we need to create two variables which will actually record those maximum minimum values, maximum ID value and min ID value. Now let me initialize this values with the first IDs of the first element in the or first object in the array equals to sptr 0 dot id, and min id value equals to sptr 0 dot id. So both are initialized in the beginning to the id of the first object. Now we have a loop, and we start from the second object, because the first object ID has already been used, so there is no point iterating from the first object. So from the second object, I less than total number of objects, I plus plus. Inside the loop, if the object which is currently being examined has ID greater than the maximum ID value, then we set that ID to this maximum ID value. So, if SPTR, this is the object which is currently being examined, has ID value greater than max ID value, then we set equals to ID. And again, to keep track of the minimum ID value, is SPTR dot ID is less than min ID value, then we set value to this ID of the current object. This logic will record the maximum and minimum ID values into the two variables, max ID value and min ID value variables. Now we can display those minimum and maximum ID values. Min ID value, max ID value, and finally and the line. This is part of pre-processing step. Let me also display this text. Let me go ahead and do compilation and see how does this code behave with compilation and execution. Compilation and linking. I think there is one small typo. I need to go back to the code to make correction. So in this loop, so this we should have a semicolon in this place. So that was the problem. Back to the terminal. So it is okay now. Execute. How many students? Let me enter 2. It is asking me to enter student ID and name. I will enter ID 1G01 and the name Jackson, and ID 2G02 Mary. Now data entry is completed and also pre-processing completed. It took this smaller value in the min ID value and the larger value in the max ID value variables. In dynamic memory allocation, you always remember there should always be cleaning up of the dynamic memory that was allocated. You must clean it up, otherwise there is going to be one important and very key issue, which is called memory leak. So if you don't clean the allocated memory, that results in memory leak problem. So finally we have a step of cleaning up. Cleaning up in this case is pretty straightforward. You can delete the array. So this is all you have to do to clean it up, and it is always good practice to set it to null PTR. Now once cleaned up, all the steps completed, let me go ahead and do some sort of modularization of this code. I am going to be converting this, putting this this different tags into different function models. That will help us to make this code appear a little bit concise, a bit readable. Therefore, to modularize this dynamic memory allocation, I want to create a function. Let me call it mem allocate, because this is for memory allocation. And to allocate the memory, I will be putting this entire thing, this code inside the function, and for this code to execute well, then we need to have information about number of student. This is something that we actually want to use afterwards, therefore it should be available in the main function. So we want to pass this number of student into the function as a reference. Let me pass as a reference number of students, and we want this function to return this address, so that we can set it to this pointer. Therefore it will return a student pointer, and you actually, instead of equating to SPTR, we just return it. So this is the function which allocate memory, and we don't need this line now. Comment this out, and we can call that function here, SPTR equals to, and pass a number of students into it. So now it will make our code look concise. Similarly, we can we want to move this part, this data entry part, into the function. So let us create another function called data entry, and in this function let me copy and put the code we want to place. I think there was a small typo in this text, so I'm going to be just copying and pasting here. So we need so you can, if you look into the code carefully, you will see this is the information we want, this number of student, and SPTR is the information we want. So we need to pass this array into this function. So the way of passing this array is going to be, because you are actually writing the data into SPTR, so you cannot make it constant, so it will be just a student pointer SPTR. This is the array, and the size, or you can call number of students. You pass these two things, and data will be read. You don't need to return, you don't need this function to return anything, like make it void. So now we can call that function here, pass SPTR and number of objects. Now it data entry completed now with this. Finally, and after that we also want to modularize this part of the code. So here this entire logic, maximum and minimum value, let's assume that we need to use, we will need this maximum value, minimum value. Therefore we want to create this these variables here in this place, but we want to put this entire thing in the function. So let me create another function called process, and put this code here. Now again we need, this function needs access to the size and the array, like in this case. Let me just copy and paste. And it also need access to this maximum ID value and min ID value, and the value that is determined in this variables should be accessible from the main function. Therefore we want to pass or receive those as a reference into reference value, and again we do not want this function to return anything, void. Now we can call this function from here, process, pass sptr, number of students, max id value, min id value, right. This is invocation, and this statement will display the minimum and maximum value that were actually found out by the function invocation. Finally, cleaning up, we also want to create a function for this. Let me call this function mem deallocate, and we only need to pass sorry, we only need to pass sptr. In this case, we don't need to do anything else. So our function will look like this: void and student sptr, and in the logic you just put this thing, delete sptr and set sptr to null btr. Right. I think this is all the changes we have already done. Let me go switch to the terminal and try to see whether we have any issues with this code or not. Compilation and execution, I think there is a problem. sptr was not declared in this scope, line number 22. Okay, here, oh, I think there was a typo. It should be sptr. Okay, we also have typo here, I guess. sptr, yeah, sp. Let me try it one more time. There's one problem, line number 52. So sptr, I hope now we don't have problem. Let's see. No problem. 3 students, 1001 ID and name Jackson, 2002 ID and name Mary, 3003 and name Christian. Now you can see max minimum value, ID value was computed and pre-processing completed. It looks like there is one final thing missing in the code. Memory deallocation completed. I think we should be fair with the deallocation as well. Yeah. So this is the end of the discussion of dynamic array of objects topic. Thank you for watching.